Okay. Um, this is the another question. Um, this is called the binary system, where you're making selection. So they tell you that there is a company. Tell you what the name of the company is. They're considering 7 possible projects. They have a budget of $6,400,000. Some projects are classified as high, some low, some projects need modification, so they're classified as mod. Now, they must have at least, they tell you must have at least one high risk, must have at least one modification, cannot manage 4 projects a year, project E needs project A. They tell you some stuff, and you see the word that you need to select. And we're maximizing profit. Now, all these numbers, cost, profit, 200, 400, 600, they're in thousands of dollars. So this is $200,000, $400,000. So for these 7 projects, you're not gonna do multiple of them. You're either gonna do a project or not. So you're either gonna select to do A or not to do A. So it's one of 2 possibilities. We call this the binary system, or project selection binary. The way we start when you do that, you're making selection. This is how we remember the 6,400,000 budget. We define the variables this way. We say let A be 1 if project A selected and 0 if not. Same for B, 1 if selected, 0 if not. Same for all of them. So all of these variables would be 1 if you selected and 0 if you don't select it. So if you say you're selecting, you end up selecting B, C, D. So this would be 1, 1, 1, 0, 0, 0, 0. Now, they tell you after this that you're maximizing profit. Remember, I'm gonna erase this line that must have at most 1 high. You're maximizing profit, so you're maximizing 600,000 of A, 1,500 of B, 1,800, C, 3,000 of D, 3,400 of E, 4,000 of F, 6,000 for G. So now we get into the subject 2. There was, before erasing this one, there was one where it's at most 1 high risk and at least 1 modification. So we'll do the subject 2. At most 1 high risk. The ones that are labeled high risk are F and G. So between F and G, you gotta have at most 1. And also modification, they're A, B, and C. They tell you for the ones involving modification, the A, B, C, also at least 1. So the 1 high risk, F and G, at most 1. The A, B, C modification, at least 1. Cannot manage 4 projects. So that means that if you add them, A, B, C, D, E, F, and G, they gotta be less than 4. because they cannot manage 4 projects. E needs A. The way we do this, when they tell you E and A, you know that all the possibilities are not to select E, not to select A, only selecting E, only selecting A, or selecting both of them. They tell you E needs A. So to have E, you gotta have A. But to have E without A, that's not good. So that means that this one is not good. You select nothing, you select the A but decide not to do E, that's okay. But the only one that's out is the second one. If you look at the ones we're accepting, so the 0, 0, the 1, 1, the 1, 0, so they either have the same value or A is more. So as long as A more or equaling E, we're good. This is how you do E needs A. At most one of the CDF projects. So the CDF, at most one. There's also one constraint for the cost. Remember the budget of $6,400,000? So if we consider the budget, it's gonna cost $200,000 to do A, $400,000 to do B, $600,000 to do C, $2,000 or $2 million actually to do D. It will cost $2,100,000 to do E, $2,500,000 to do F, $3,600,000 to do G, not to exceed $6,400,000 and thousands of dollars, but to be consistent, only put the 4 numbers. This is how you do this problem, and at the end you say all variables greater than or equal 0 and binary. If you don't say and binary, it's okay. But this is how you do the binary system or selection. Thank you.